Hi, this is CS6898. I'm here recording the second part of the assignment. So, before we actually run anything, we have to disable ASLR. I've done that already. I'll go over sol.py. So, sol.py, this is the file that actually brings up GDB and inserts binary data into the file we're debugging. So first, this file, when this runs, it actually gets the address of the leak. Address of the leak is the same as the address of the buffer, which we want to overflow. Then there are a few debug prints here, and then we get the shell code. So once we have the address of the leak, we need to get the shell code. For the second part of the assignment, we're tasked with coming up with the shell code that it does not have any null bytes. So this is the shell code that does not have any null bytes. This is the byte string that can be injected so that the shell comes up, right? Uh, Details on what's happening with each of these instructions are captured in the report. So once we get the shell code here, the program then asks us for the total length of the data we're injecting into the buffer. In this case, it's 104 plus 8, which is 112 bytes. We send that across. It's 112 bytes because it's 104 bytes is the size for the shell code and the no-op padding, and 8 bytes is for overwriting the return address. So once we send the total length, then the program asks us for the total, asks us for the actual data. So we send the shell code and no-op padding, so many bytes of no-op padding, 104 minus the length of the shell code bytes of no-op padding, and the address of the leak, P64 of the address of the leak. P64 basically packages the address of the leak into 64-bit format. So that's it regarding the functionality of the shell of sol.py. Then so when we actually run this, it brings up GDB, and I've set up a few uh, commands to run when it comes up automatically. So first is set up a breakpoint on line 41. 41 is this line. That breakpoint will be hit just before we read any contents on uh, uh, into the buffer, right? And the second breakpoint is on line 51, which is the last line of the function. So between these two, we'll be able to inspect the contents of the stack before and after we inject the data and validate if the injection is working as expected or not. So after that, so we set the two breakpoints, then we continue till we hit the first breakpoint, and then we inspect the contents of the stack. So all this is run automatically when the file is brought up. Another thing is the context binary is set as main. We need to compile this file with so many flags. I've done that already and saved it as main. Right. So now let's see the attack in action. Just start with Python sol.py and yeah, so the first breakpoint is hit here, and we are able to see the contents of the stack. We go to the other console. The address of the leak is logged here. The last four characters of the address of the leak are 8130. The first so many characters will remain the same, so I'll just refer to it as 8130. This is where the buffer starts, and 90 bytes from from where the buffer starts is the uh, is the actual contents of the buffer we have seeded. So there's 90 bytes of null characters because that's how we have initialized in the code. Then uh, this address uh, ending in 8198, right? So this is what contains the return address for the function. This is what we want to overwrite. So we place the new return address here. What do we do? So we actually insert the shell code here in the buffer, and then point 8198 to this address 8130, right? So that uh, and so when the function finishes execution, it goes back to 8130 and starts running the instructions there. Since we have added instructions to bring up the shell code, it'll bring up the shell. uh, so if I hit continue, we should hit the second breakpoint, which is the last line of the function. If we inspect the contents of the stack here, At 8130, we have injected the shell code, and then there is a few bytes of no op padding, and after that we have at address 8198, we have overwritten it to point to 8130. So first, how many bytes remain the same again? So it points to 8130. So the injection into the stack, the buffer overflow is the contents of the stack are what are as expected, right? So if I hit continue now, the shell should come up. So let's see. Yeah. So we see that a new program bin dash is being executed. Dash is just another way of bringing up the shell. And yeah, so we were successfully able to bring up the shell. Now if I hit close, it says the sh was stopped, right? So this shows us that we were able to bring up the shell without using any null bytes. So the expectations for assignment 2 were met. And again, just like the previous assignment, bin dash is the same as bin sh. I can show that quickly. Slash bin. So this will show all the contents of the directory slash bin, and I'm grepping sh. So you can see that sh is pointed to dash. So bringing up bin sh is the same as bringing up bin dash. So we were successfully able to achieve the objective for the second assignment. We injected the shell code without any null bytes, and we successfully implemented a buffer overflow attack to bring up the shell. Thank you.